Now we get to play with data. Let's say we are teachers and we need to make sure the assignment grades are similar to, but not identical with, test scores. Because if they're too dissimilar, then the tests or the assignment might not be assessing students effectively. And if they're too similar, then we're not meeting one goal of having different assessment types, namely that students are different. They have different strengths and they get to showcase those strengths. So we want to test, so we want the test and written assignment scores to be similar but not too similar. And I'm just going through and changing up the labels to make them a little simpler. So instead of student number, we'll just say student. Instead of all of this extra stuff, we'll just say this is test 1. Test 2, test 2, test 3, test 3. Okay, what do I actually need here? I'll need the final grades, probably. Be good to have. I'll just delete these denominators. Okay, you'll notice that I'm starting with an Excel file because I think this will be a little more representative of what you'll be doing. I'll probably be most interested in test 2 and the assignment score. So what I'm going to do is I'm going to save this as a comma separated value file, and I'll pick the funny one, the UTF-8, just to show you what to do in case you end up with a file that is UTF-8 rather than just a normal plain CSV file. Okay. Good, save to CSV. There's a 0 here. That may or may not be important. Lower my average a bit. Somebody didn't hand in an assignment. It happens quite often. What I'm going to do here, so I don't have junk on my desktop, but so that I have the relevant course grades in their own place, is I'm going to engage in what's good behavior generally, which is every project gets its own folder, its own working directory, in case you have something with the same name and you don't get confused and access the wrong file. Open up R, and now we have to set the working directory. I'll do it from the menu, from the drop-down menu this time, just because we did it the other way before. Course grades. There we go. So that set the folder, set the working directory, which is a folder. And now I'm going to create an object, and that object is the data in the file that I just showed you. So I'm going to read a comma separated value file, and I called it course grades. .csv. And here is the bit that you wouldn't necessarily need with a normal comma separated value file, but since I had a UTF-8, I'll say file encoding is UTF-8. This just tells it what to expect from the file, how to read it properly. And did it read it properly? Looks like it. Now that's a little few too many, so what I'm going to do here is I'm just saying, just show me the first 4 rows of data. Notice that it also shows me the header, because by default, R assumes that the file has a header. You never have to tell it that there's a header. I can tell it that there's no header. Look, header, false. Header equals false. And now, what I did was I told R that this file doesn't have a header. I lied to R. Now what happens if I tell it to just show me the first 4 columns? Well, it thinks that the first column of labels of headers is data. And it automatically names the variables v1, v2, v3, etc. So I quickly changed that back. And I could just have it show me 1 row if I wanted to. I could just have it show me the assignment variable if I wanted to. There we go. So next, what if I want to plot this data? I could, well, first of all, what if I just tried to plot it right now? So before attaching anything, what if I just tried to plot it right now? I said plot, interest in test 2 and assignment. Plot it. Oops. Wait, why can't you find test 2? You know what it is, right? No, you don't. You don't know yet. I need to attach the data object. What does that mean? It means whenever I refer to something, assume it's in the data object. So then I hit the up arrow and it gave me the graph that it wouldn't give me before. And it looks like there might be a weak relation there, probably about the degree of relation I want. And just to show you that R has a lot of power, I can graph or communicate information from a third variable here. Namely, let's bring in the student number as labels. Keep in mind these are not the actual student numbers. I changed them with some random numbers. And but wait, students. It's actually called student. There you go. Not only is it case sensitive, you actually have to get the name right. So we have student number superimposed on our nice Cartesian test 2 and assignment data. A little sneak peek of how powerful R is in terms of being able to display multiple variables. So let's save this because we love it so much. It's so beautiful. It's not, it's hideous, but we're going to save it. And then we're going to reopen it. How do we get back to the workspace of our course results? The best route is usually to open the saved workspace in its folder. When you open this, it opens the working directory, but it doesn't remember what objects you had available or attached. So my first action is to tell R to look for objects in the data object. Did it find it? Yes. So we got it. Our purpose here was to see whether test 2 and the assignment were correlated, but not too correlated. Without downloading anything fancier, we can do this for test. And what are our results? We see that we have a statistically significant correlation. In other words, in the world where test 2 scores are not related to assignment scores, these data are only 1% likely, so we're probably not in that world. This p-value tells us zilch about the actual magnitude of the relation. That's what Pearson's R is for, and Pearson's R is 0.41. 0.41 is a correlation of moderate or medium strength. About 16% of the variation in assignment scores is explained or predictable from variation in test 2 scores. We can plot this again. We can see that there are 2 students with very low scores, and not only do they have very low scores on one assessment, but they also scored below average in their other assessments, meaning these students are likely exaggerating my correlation, making it larger than it should be. To visualize the potential outlierishness of these variables, we can just do a normal generic box plot. So we have our box plot for test 2 and our box plot for assignment, and we see that these low scores are indeed outliers, so these are improbable scores. So far we've just used defaults and the functions that R has built in, so let's download something fancier. Let's download ggplot2. Packages, install packages. Let's choose... no, Canadian options. Ohio's pretty close. Let's choose that as our mirror. And we are after ggplot. Specifically ggplot2. ggplot2, okay. Now we have ggplot2. We just need to call it. So our library ggplot2, and that calls it. So now we have a package called ggplot2, which helps us to make new cool things. Remember our old plot that looked like this? Well, we can do the absolute simplest plot in ggplot. Keep it nice and simple because the learning curve for ggplot is a little bit steep. We can just do qplot. Now that we have ggplot, we can just do qplot, which generally accepts the same commands as the normal base plot function in R, and boom, prettier. So that was a first look at playing with our data and some of the things that R does very simply, very easily, very quickly, and very powerfully. Next time we'll play around with some more informative visualizing.